I'm going to show you three different calculations here for Q factor. This is the most common one, and I've looked at all 11 problems that they've written on resonance systems, and I've seen this one 3 or 4 times. Okay, so let's spend some careful time on this, right? Okay. Remember, this is the example I showed you. We think our Q factor here is 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10, right? Q is approximately 10 for this guy, right? So let's do some careful reading here, okay? We're going to use this formula here, 2 pi energy stored over energy dissipated per cycle, okay? What we're going to do is this. We're going to look at this spot right here. This is after 1 cycle, so this is our energy stored. Energy stored is that initial energy, really. Okay, energy dissipated per cycle is going to be the difference in energy between there and there. It'll be the difference in energy from the beginning to the end of that first cycle. Now we could go from this to this, and hopefully we'd get the same number, right? Okay, but I'm a little unsure, and I think this is kind of an approximate calculation. I think there's really a differential equation or something. Okay, but let's look at this first one. This is the kind of calculation that they use. Okay, to do this, we would have to do this. We'd have to say, okay, Q is 2 pi, and remember this is our total energy, right? It's based on the mass and the omega and the x naught, right? Okay, but remember this is a ratio here, so some of these things are going to divide out. Notice that we don't know the mass, we don't know omega, although we could kind of figure it out, right? But we don't need it. I'll show you. Okay, so Q is 2 pi, and in the numerator we've got 1/2 m omega squared, and then our initial amplitude is 2. So I'm going to go 2 meters squared. Okay. And then in the denominator, we've got the energy loss. So it'll be this minus this energy. Okay, so 1/2 m omega squared times 2 squared. And then here it looks to be about 1.2 minus 1/2 m omega squared times 1.2 squared. Now, notice that the 1/2 m omega squared is in every term in the numerator and the denominator. That means we can cancel it out, which is good news for us because we didn't know, they didn't tell us what omega was. We could figure it out, right? Omega is 2 pi over 2, it's roughly pi, right? But we don't know the mass, definitely, right? But since it's the ratio of these two, those things cancel out. So our calculation just becomes this. Q is 2 pi 2 squared. In fact, in the mark schemes, they just do this. They don't even bother with canceling that or showing anything. They're just like, you should just know it's this. Okay, which I don't know. It's not my favorite. Okay, so let's do this calculation. So we'll go 2. Whoops, got to turn your calculator on first. 2 pi times 2 squared divided by parentheses 2 squared minus 1.2 squared. And when I do that, I get about 9.8, which, you know, if we look at this thing, we said the Q was approximately 10. We just calculated this 9.8. That's pretty close. In fact, you'll see when you see these problems, it's very sensitive to your reading of that. If we put in 1.3, I'll just do it. Let's suppose we thought it was maybe 1.3. I get like 10.8. I get, you know, it's highly sensitive. This you'll see in the mark schemes. They'll say accept any Q value between 21 and 43 or something like that, right? So it's like anyway. So this is sort of the main one that I've seen, but I'll show you a couple others.